Welcome back. We are in the live classroom doing physics for class 12 based on the board examinations which are very near, and we had discussed a few questions from sample papers, the latest. Now we will continue with the remaining questions as well. So let us say the next question, you have a look at the question. Three identical Polaroid sheets P1 and P2, P1, P2 and P3 are oriented so that the path axis of P2 and P3 are inclined at 60 degree and 90 degree respectively with respect to the path axis of P1. A monochromatic light source intensity I0 is kept in front of the Polaroid sheet P1. Find the intensity of light as observed by the observers O1, O2 and O3 positioned as shown below or as shown in the figure. Right? So it's again a question in different ways it can be asked. So I'll explain it over here. Listen now. This is the source with intensity I0. What kind of light it is? It is unpolarized light. This is a Polaroid. As light passes through a Polaroid, the intensity will be halved. You know, the vibrations associated with electromagnetic waves that would be filtered out as it passes through as the unpolarized light passes through the Polaroid. So the intensity of light at the as far as the observer O1 is concerned, the intensity of light becomes I0 by 2. This is just by the concept of what is a polarization. Half the vibrations are getting cut. That's why intensity becomes half of initial. Now, depending upon how the second Polaroid is oriented, it is given between these two Polaroids, the angle is 90 degree. Between P1 and P3, the angle is 90 degree. Between P1 and P2, the angle is 60 degree. You know which concept you are making use of here? This is based on Malus law. You know Malus law concept you have studied. Malus law says the intensity of the light coming out of the Polaroid is equal to I0. I0 is the intensity of the incident light, then cos squared theta. I0 cos squared theta. This is the equation we have for Malus law. But the thing is that remember this I0 over here in this expression indicates the intensity of the polarized light falling on the Polaroid. But here in this question, in this context, I0 is not the intensity of polarized light, instead it is the intensity of unpolarized light. So as far as the Polaroid P2 is concerned, the intensity of the incident light is polarized light is I0 by 2, not I0 but I0 by 2. So what will be the intensity as far as the observer O2 is concerned? For the second observer O2, let me write that as I2. How much is I2? That is intensity of the light as far as the second observer is concerned. For that we should look at the angle between these two Polaroids. Between these two the angle is 60 degree and the intensity of incident light is I0 by 2. I0 by 2 into cos squared 60. You know cos 60 is 1 by 2, half. So cos squared 60 is 1 by 4. So the answer is I0 by, this is 1 by 4 into 2. So 8. So I0 by 8. I0 by 8 is the intensity of the light as observed by the observer O2. Okay. Now look at this third Polaroid P3. As far as P3 is concerned, the angle between these two is how much? See, between P1 and P3 the angle is 90 degree. Right. Between P1 and P2 the angle is 60 degree. Whereas between P2 and P3 the angle will be then 30 degrees. Correct. 90 minus 60. So this angle is 30 degrees. Clear? So but there we can make out this way. The intensity of light as far as the observer O3 is concerned, what will be the intensity I3? Is equal to, what's the intensity of light falling over here? That is, we have got it as I0 by 8. So I0 by 8 into cos squared, what's the angle between these two? 30 degree. How much is cos 30? Cos 30 is root 3 upon or root 3 divided by 2. So cos squared 30 would be what? That is I0 by 8 multiplied by cos squared 30, root 3 squared, that is 3. Root 3 by 2, so 2 squared, that is 4. So what's the answer to this? 3 I0 by 8 4s are 32. All of you have seen this answer. So you look at the diagram first. There are, once again let me tell you, this is a very important concept. There are three Polaroids, P1, P2 and P3. P1 and P3 are inclined at 90 degree with each other, and P1 and P2 60 degree, therefore P2 and P3 30 degree. So this intensity is I0, so this will be I0 by 2, then I0 by 2 into cos squared 60, then that into cos squared 30. So we get this. So be very clear, whenever the question of this sort is asked, you should first make sure, is the value I0 given? Is it the intensity of polarized light or unpolarized light? That's very important aspect to understand. Okay. So now let me tell you a few more questions. See, look at the next question. See the question. The modulation index of an amplitude modulated wave is 0.55. What does it mean? It means the ratio of the amplitude of the modulating signal to carrier signal is 0.5. That is AM by AC is 0.5. All right. And look at the next part. Calculate the modulation index for an AM wave for which the maximum amplitude is A and minimum amplitude is B. So that is, it is given the maximum amplitude, let me say A max is equal to A, and minimum amplitude, that is A minimum, is equal to B. So what the question, we have to calculate the modulation index. Is clear? Modulation index. Now look at this. See the board. What's the equation for modulation index? Mu is equal to AM by AC. That is amplitude of modulating signal to the amplitude of carrier waves. Right? Is equal to. But how do you get amplitude of modulating signal? Look, for that these two values to think of. Maximum amplitude, when do we get maximum as far as vector addition concept is concerned? We get maximum amplitude when the amplitudes are added up. Minimum is when they are subtracted. So max means AC plus AM. This is the maximum. That is given as A. How about minimum? AC minus AM. Okay, that is minimum. That is given as B. Now what you do is you add them, these two expressions we add. What do we get? 2AC is equal to A plus B. These two cancel. Right. So AC is A plus B by 2. Right. By the way, this is what you get as when you add them. But when you subtract one minus this minus this, what do we get? AC minus AC cancel. This minus this is 2AM. So 2AM is equal to A minus B. So what do we get if you divide this by this? See, AM by AC, this by this is equal to A minus B divided by A plus B. This is the answer. Once again, the answer to this question, the modulation index mu is equal to A minus B by A plus B. What is A here? A is the maximum possible amplitude, B is the minimum possible amplitude. Maximum amplitude to minimum amplitude, this is the expression for modulation index in terms of maximum to minimum amplitude, maximum amplitude and minimum amplitude. Is that clear? Now look at the next question. So the next question is, write the formula for the velocity of light in the material medium of relative permittivity epsilon r and relative magnetic permeability mu r. So epsilon r, mu r, relative permittivity and relative permeability. Okay, so this, how do you write the value of the, how do you write the velocity of light in the medium? Okay, now listen. So when you say epsilon r, mu r, in terms of these, we are going to say the expression, we have to write the expression for the velocity of light. You know the expression for velocity of light in vacuum, we know the equation 1 by root of mu 0 epsilon 0. But this is a medium. So what you will write here, the velocity of light in the medium is equal to 1 by root of, instead of mu 0 epsilon 0, that is for vacuum. If it is a given medium, you will write mu epsilon. But mu and epsilon you can write even in terms of relative permeabilities and relative permittivities. Correct? What you will write here, therefore, that is 1 by root of mu 0 mu r into epsilon 0 epsilon r. Correct? Mu 0 mu r into epsilon 0 epsilon r. But 1 by root of mu 0 is epsilon 0 is c. So we may write this as is equal to c divided by root of mu r epsilon r. This is the expression for the velocity of light in the given medium in terms of the relative permeability and relative permittivity. Relative permeability, relative permittivity. Okay, in terms of these two, this is the expression for the velocity of light or electromagnetic wave in the given material medium. Is that clear? Okay, so now look at the next question. See the question again. Box A in the setup shown below represents an electric device often used to supply electric power from mains to a load. It's known that the VO means output voltage, is less than input voltage. So identify the device A. What do you understand? Look at the diagram carefully and see what kind of device it is. Basically, we are reducing the AC voltage, So A represents a step down transformer. A represents a step down transformer. Then what is identify the device A? A is a step down transformer and draw its symbol. What is a symbol? See the symbol of a transformer, we draw like this is a coil. You see this is the symbol of a step down transformer. See this is a core, symbol of a step down transformer, right? And you don't get confused with symbol and schematic diagram. The schematic diagram is the one which we are usually drawing. Say one type of schematic diagram you drew is like this. It's an iron core, right? And this is the what you call as the primary coil. Okay, here we have the secondary coil. You see this is the schematic diagram of a step down transformer. You have to draw less number of turns in the secondary. So you should label it as this is primary, this is secondary, this is iron core, like that you have to label it. And this one is the symbol of a step down transformer. Okay, so what is the continuation of this question? You read the question again. This is the first part I mentioned about. Then B part is draw a schematic diagram and explain its principle and working, that mutual induction. Then you have to describe about the working. Obtain expression for the ratio between its input and output voltages, that is Vs by Vp is equal to Ns by Np. Then find the relation between the input and output currents of this device, assuming it to be ideal. Assuming it to be ideal. You see the concept. Okay, you see, let me tell you something about that part. Ideal transformer means what? There is no power loss. We know the losses can be by the loss due to formation of eddy currents, then flux leakage can be there, then what is a hysteresis loss. All these kinds of losses are possible in the case of transformer during the transmission of the electric power from one point to the other. Here we have a step down transformer. Whatever is the type of transformer, the power losses are there due to the use of transformer. We will take measures to keep the power loss as minimum as possible, like the laminating the core to minimize eddy currents, then coupling, winding one coil over the other for minimizing the energy loss due to flux leakage. So there are measures, and we are using iron core to keep the eddy current loss as minimum as possible. Iron has got a soft iron core. Soft iron has got a very low energy loss due to hysteresis. So all these we will minimize it, but still there are some reasons for the energy loss. Always it exists, but if you for calculations, for numerical problems, what we do is we consider always transformer as ideal. Ideal transformer means what? We assume there is no loss of power. If there is no loss of power, it means input power is equal to output power. Input power, we will say Vp Ip. This is input power. Should be equated to Vs Is. P is equal to Vi. Input power is equal to output power. So what we will get for Vs by Vp? Vs by Vp is equal to, therefore, Ip by Is. See, this is the relation between the input and output currents if assume the transformer as, or if we assume the transformer as ideal transformer. Is the point clear? All right. Now we have more questions, but again we will the next week again we will have a discussion on the questions. Basically I'm planning to, anyway now we have, it is the time for us to wind up this today's classes. But before we finish off the class, let me remind you about this one to, next week only you will be seeing again. During the course of time, in case if you find any difficulties, definitely you feel free to contact us, because we have to help you out. The exams are very near and all of you are in a serious preparation. Okay. And what else is, I mentioned about the take a test at home provision. So make use of that. Visit the ntvuae.com website, ntvuae.com, and there is a provision given for you to take a test at home. Make use of that, and let's see how you progress. And next week I'm planning just to clear your confusions, and I'll just give you the last moment tips. I'll give you a few more points to add up with what we have discussed last class. But next class I'm planning to do some questions for 10th grade as well, after clearing your confusions, if any, or after giving you a few more tips. We'll divide like half the time we'll spend for class 12 and remaining half for class 10. They also have exams coming up. Okay, so have a nice time, have a good exam, and anyway you're going to start your the exam on 1st of March. Alright, the coming Saturday is your first examination. So all of you are maybe eagerly waiting for the English examination coming up for CBSE students. Okay, so that will be obviously it's going to be a lighter note. Let's pray for it. Alright, so I wish you all the best to each and everyone who is watching this program, and even all my praise to you. Let's enjoy the examinations. Okay, so see you again next week. Have a nice time.